Good afternoon. This is a demonstration of my MatLab file exchange project, the Fermi Paradox simulation tool. Within this tool, you can explore how a civilization would expand throughout a universe by varying different parameters about the spread of stars within that universe, as well as civilization level parameters. That is, how long the civilization will last and how long they are able to send out probes. You're also able to vary aspects about the probes themselves, how far they go, and how fast they go and how long they last. If you are not familiar with the Fermi Paradox, there are plenty of resources online to familiarize yourself with that. Within this tool, you are able to do both single run simulations and Monte Carlo style simulations. The single run will let you visualize the universe as a civilization expands throughout it. To get into the meat of it, let's start a civilization here with the default parameters. So here we have a map of the civilization of the universe with the civilization expanding. So occupied star systems are in green, unoccupied star systems are in black, and uninhabitable star systems are in red. As you can see here, with our current parameters, it took approximately 40,000 years for civilization to spread through the observable universe. Here we go. Discussing what's plotted here, we have up top the universe, showing what systems are and are not inhabited, as well as inhabitable. The next plot down shows what percent of star systems are inhabited. The black line here represents the percent of which are inhabited. In this case, we have set 75% of star systems to be inhabitable. And you can see the percent slowly rose up, and when we got to 90% of the inhabited percent, the simulation was cut early with this checkbox enabled. Down here, the lower plot, that is showing the expansion rate of civilization. That is taken from where the first star system was settled to the furthest star system that is currently settled, and dividing by time, so you get an expansion rate. By and large, my observations have been that the expansion of the civilization is approximately half the speed at which probes are able to be sent out. Going back to the GUI to discuss some of the parameters, we have some simulation setup terms up here in the upper left: simulation time step, plot update rate, maximum years to simulate, the dimensions of the universe, in this case 150 by 150, and the number of initially inhabited spacefaring star systems to start with, in this case 1. Then we have a sub area for properties of the stars and how the universe is laid out. In this case, we're specifying the average distance between stars, in this case about 4 light years, the relative motion of stars between each other, in this case it's about 30 kilometers per second, and the percent of settleable stars, here we are at 75%. Within the bottom center section, we have parameters about the civilization. In this case, here we have civilizations will last 5,000 years and then go extinct. Once a civilization has gone extinct, that star system is dead but can be re-inhabited from neighboring star systems. Next, we have how many years it takes for a civilization to be able to develop a probe, to be able to send out to another, to start developing probes after that star system was arrived at by a probe. So a probe will arrive in a star system. It takes, in this case, 100 years for the civilization to establish itself before it can start building another probe to send on to another star system. Down here, in the bottom of this section, total number of years it takes to build a probe. Probe, in this case 100 years. About the probe, this is the speed at which the probe is able to travel from one star system to another, in this case as a fraction of c. So here we are 0.01 or 1% the speed of light. And you also specify the age of the probe, the maximum age of a probe. That is, how long in time is it able to travel between star systems will remaining functional. Now, to vary these parameters a little bit, we can enter into here. So the actual distance between stars near Earth is about 5 light years. So let's change that. Let's make things a little bit harder with a 60% settleable rate. Let's say civilizations, and it takes 500 years to build a probe. And let's say the probes are only able to go 0.5% of the speed of light. And we still have the checkbox, so civilizations will start in the center of the plot and expand from there, and the simulation will end when 90% of the settleable stars are settled. So clicking run, and we can see, yeah, it is a little bit slower and a little bit less sparsely populated, but you can still see civilization is spreading throughout the simulated universe and was more or less occupying everything within the 100,000 years. Also, there is a summary of the simulation setup printed to the command window. What some of you may have noticed is that we also have the Monte Carlo simulation option. So let's just reset our terms to default. This does use the par4 or parallel processing toolbox. If you don't have that, it won't use that. And let's try 1,000 simulation runs. Let's take the settleable percent down a little bit more. Maximum fraction. So yes, these all look good. And we have two different Monte Carlo simulation run options. The first one is where every run of these 1,000 vary all these parameters, and the civilization and probe parameters remain fixed throughout that simulation run, where the lower option will have the star parameters fixed for each of the 1,000 runs, but then when a probe reaches a new star system, the values for the simulation and probe will be randomly generated, and not dependent on the civilization that sent the probe to the new star system. The results between these two are basically the same, where you get civilization spreading throughout the observable universe within the time frames as specified by the probe speed primarily. So now I'm going to click run. Here we go. Okay. That simulation took a little over a couple minutes on my moderately new computer, but your mileage will vary based primarily on how many runs you're doing and your hardware. So the first figure we have here is a percent of each of the 1,000 runs, percent of the universe inhabited as a percent of what is inhabitable. Most of these civilization percents can be modeled by a sigmoid function, which I've done here. So you can see the sigmoid growth rate K in the lower left and the sigmoid inflection point in the lower right. So by and large, most of the parameters that it came up with, it was able to inhabit the universe. Now going on to other plots, here we can see the final settleable percent as a fraction of the settleable planets. So in the middle here we have a histogram that shows the final settleable percent of settleable star systems. So there was very few that were not fully inhabited, relatively few in the middle, and then a whole bunch where more or less everything was settled. The lower plot here, we show the maximum drawdown. That is, how far did something go down after hitting a new peak. By and large, these numbers are similar to what I've observed in that things tend to just grow. The next plots we have are the cross-plotting of various parameters within the simulation and the final settleable percent, as well as a correlation coefficient showing how much of an influence that that parameter had on the final result of how many star systems were settled. By and large, what I have observed is that the probe speed or the probe range has the largest effect on what final percent is settleable. That is, if you're able to send out fast probes or probes with long range, you will end up settling the observable universe. And each of these individual x-axis labels should be relatively self-explanatory with what they're plotting from the original GUI. Also, I plot out the expansion rate as a function of each of the independent probes. And again, probe speed or probe range are generally have the highest correlation to expansion rate. Within the GUI, you have the other simulation option that produces largely similar results, and you can work through those on your own. Again, the files for all this are available in my MathWorks file exchange repository. Please download from there. Any questions you have, please put in the comments here or in the MathWorks file exchange site. Thank you.